triangle has how many degrees in it?
Well, if you add up all the all the angles, it adds up to 180 degrees.
Interior angles, right. So we know that if you have to find the value of a triangle in degrees in, say, algebraic equations or geometry, so to speak, like point line graphs, you're going to take both inside outside vertices or both adjacent angles. So if you had a right angle, you would measure the inside and outside of both of those. And this is something that's like simple. The concept is simple. You add all 6 angles up and you get 540, and then you subtract the interior and you get 360.
From what shape is that?
From a triangle.
Oh, right. What? No, if you add up the interior angles, it's 180.
180, yeah, totally. Just interior angles. But who does mathematical equations with only 180 degrees in a triangle? Nobody. Nobody that does mathematical equations does that. They assume that a triangle is on a 2D plane, therefore is surrounded or covers all sides, including, which means radians, essentially. Like you're looking at the circumference of a triangle. If you turn the circumference of the triangle into a circle at 360, changing the shape of the lines doesn't make it 180 degrees, because you start at one point and you end back at that same point. You see what I'm saying? And
not exactly, but my friend is an engineer and he knows more,
okay.
and I'm going to see if he can get on here.
What up?
Hi.
Hey. I guess if you were talking about non-Euclidean, then you can, I guess, argue what you're arguing. But if it's Euclidean geometry, the interior angles are always 180 degrees.
But, okay, give me a Euclidean mathematical equation.
Euclidean mathematical equation? Well, the Pythagorean theorem?
An equation that's the Pythagorean theorem, which says that all lines make triangles, make circles, make squares, make stars. Like, what is the point of that? What math are you doing with that? Theorem? Like, oh, look, you have 5 sides, you have 5 lines. That's like grade 5.
Right. I mean, it's grade 5, but we use it to make like trusses so things stand. I mean, that's kind of like the whole point. But you need some of the angles to, be able to distribute stresses through different members.
Okay, yeah, right. So if you put this triangle in a CNC machine and you have to make a triangle with a CNC machine, would you utilize 180 degrees or would you utilize 360 degrees to make this? Say it's a pipe, okay? It's a pipe that has to make 3 bends to make.
Well, I guess that's your reference. I mean, you can use the quadrant, which is 90 degrees. And then you can draw from there, but like you're going from a quadrant to a quadrant to a quadrant, which ends up being, I guess I can see that kind of logic. But at the same time, if you're, drawing a line through one quadrant to another quadrant to another quadrant, and then you add the interior angles, it's 180 degrees.
But if you have to add that other quadrant, what does it become? 360. But if you're only doing the interior angles, what does that suit you? What does that suit you if you're only doing interior angles? Like, okay, that's other than knowing the interior angles of a triangle are 180 degrees, there's no fundamental need for that knowledge.
Well, it's just
because it's
just
example.
If
we take a circle
of mathematics.
Yeah, that's all this is.
Here's how we check them. Let's check the math on
it. Doesn't really do anything other than describe itself. That's what like the axioms of math do. That's all they're really capable of doing.
Well, that's one of the paradigms of math also, is like we look and we see that something is one thing, right? But it also can be another thing. It could be another factor. A factor. An integer is just one of many different types of polynomials. You know what I'm saying? Like it's the same. It's like tomato. If you take a circle and you measure the outside circumference and find the degrees of the circle, you're going to find 360. You find the interior degrees of the circle, you're going to find 360. Add them both together, you get 720. You subtract the inside, you're left with 360. You could do that with every single shape except for the triangle, where you can add the interior and exterior and you end up with a different number.
No, because if you have like a square, right? Your square is at a 90, and then everything else is 270. Say if I'm at like using a 30, 60, 90 triangle, you can be at a 90
What does
at
that
like
what does that
at a
add?
quadrant, and then the rest of it's 270. And then say you go to like the 30-degree angle, and then now you have 330, and you can go up to the remaining one, and then that's 300 degrees.
That's a
So
but
you're
you
drawing a
can't have
circle at the intersection of the
but
corner of a triangle.
if you add the interior angles and exterior angles for any other object except for a triangle, you're going to end up with a different number on the inside and outside, adding them all together. And the reason is because you think that 90-degree angle that you're bending, if you straighten it out, it's a 180.
But then it's no longer a triangle if you're bending it into a line. I'm confused.
So why do we not count the invisible line? So we take the invisible angle, which is the 80, it's the 180. So you have a straight line. You take half of your protractor, and you're going to have half a circle. That means one side to one side of the line. Okay, that's 180 degrees.
Where is this? I don't understand how this is practical. Are you trying to prove that interior angles for a triangle is silly? Is that what you're trying to do here?
Like, Trey, you're muted. So I took a equilateral hexagon, and I did the math. The interior angles are 120, which means the complementary angles, or whatever we call those, are 60. So if you take the sum of all the interior angles, which is 720, minus the sum of all exterior angles, you get 240.
Yeah.
Okay, so that's what that is. So, but for
Your
the triangle,
supplementary
we
angle?
get 180, and then if we do the complements, that total adds up to 360. But when we subtract the interior angles, it brings us back to 180. Like, is that the point?
You're not understanding what I'm saying. So
I was afraid that was the case. Help me out.
Okay, so if you have an angle, name your four angles? Your quadrilateral. What are the four angles? I didn't hear you.
The four?
I didn't hear you.
What I was talking about with a hexagon?
Oh, the hexagon. A hexagon. See, this is a perfect example. The hexagon. That's a perfect example. So if we have 6 sides, you're adding 2 triangles.
A hexagon? No, a hexagon would be 2 trapezoids.
No. A hexagon is 2 triangles.
No. A hexagon can't be 2 triangles.
Draw a triangle facing up. Draw a triangle facing down.
That would form
overlap them.
That would form not a rhombus necessarily, but it could form a square. It would form any. What the hell do you call just a generic 4-sided polygon? I don't know. My brain's not working.
4-sided polygon? You mean a rectangle?
Well, no, it wouldn't necessarily be a rectangle. It could have acute and obtuse angle. Yeah, quadrilateral, right?
Yeah.
Yeah. So two triangles form a quadrilateral, not a hexagon.
Right.
2 triangles form a quadrilateral, not a hexagon. Let me 1 second. 1 second. I need some.
I'd love to see you try to draw this on paper.
Yeah, because I don't get it. I don't get what the hiccup significance is.
Trump of God says gravity's a lie.
Well, we're not talking about that yet. Trump of God.
Yeah.
No, boy.
Gravity definitely exists.
All right.
But not in a sense. I do believe in gravity.
Nice. I mean, I got a whiteboard. I could draw.
Okay.
If I drew a triangle, would we make any progress?
Okay, wait a sec. I'm gonna.
Folks, if you're just tuning in, what you need to know is we have no idea what we're doing. And if you've been here since the beginning, sorry.
We're trying to prove that the sum of two triangles is a hexagon, so.
No, I don't think we're doing that. At least
Oh,
I hope
okay.
that's not what we're doing.
At least that's what I gathered from it. I don't know.
Okay, so I drew a triangle. And it's got sides 30, 110, 40. I think that adds up to 180. So you're talking about the complementary angles of each of these, right? So if we took the complementary angles and added all those up, that would add up to 360. And then if we subtract the interior angles, we get back to 180, right? I don't know if that maths, but I think so. I had a great quote yesterday. I made a bunch of people laugh. I said, that math don't math, because we were counting something up and our numbers were off. And so I said, that math don't math. Everybody.
Oh, man, I have a similar saying. The math isn't mathing.
Yeah.
So we have two triangles and the exact same thing. You have your hexagon, okay?
Right.
Same
That's
thing.
not two Trey, that's
Bro,
not
that's
two
not
triangles.
two triangles.
Two triangles would make like the star of the two triangles in there make the Star of David, which isn't a regular polygon, but that's two triangles, and then well, that's actually so funny enough. What you have there is there's a smaller hexagon in the middle, and then it's surrounded by a whole bunch of triangles. $150 plus $140 plus $70. That's $360.
What I'm talking about is this. Okay, we have right angle triangle, right? Okay. So that's the one to do it. And we have right angle right there. Look. Okay, you have a 90 here. And if you continue on with the lines, supplementary angles, continuing on into infinity, you now have 45 here, 45 here. So 45, 45, 90.
Right.
So, yeah, 140.
Yeah.
100, 140. You can't have that because the angles have to equal, they have to equal 180 each one because they would not meet up, okay? So if your angles are in a point of space, they're in a point in space, right? Yeah, 40, 140, 150, 30, and 110, and that would have to be
70.
Or that's 100, is that 110? That's
It's
100.
110.
So yeah, it would have to be 80. That's 80 degrees, not 40 degrees.
No, 110 plus 30 plus 40 equals
110,
180.
I thought it was 100.
No.
So yeah, they all add up to 180, right?
Yeah,
Not
the
if you
interior
continue
angles.
them on.
Yeah.
Look, okay.
Yeah, and
You
the
see how-
complementary angles, or whatever they're called, add up to 360. And if we subtract the interior
Yeah,
angles,
okay.
we're back to
So we
180.
have,
I
like you said,
don't know what the
70.
point is though.
Yeah, that's what I was trying to ask earlier.
now
What is
add
your
them
point?
together,
Add
And
what
subtract them.
together?
and you're going to come up with 360. But you can do this with every other single. So a circle, 360 on the inside, 360 on the outside.
But
Okay.
what is there aren't any angles in a
Because-
triangle though.
The triangle,
Or sorry, in a circle. I meant to say circle.
the triangle is a space within the circle. That's what I'm saying. The triangle is a space within the circle. Yeah, because there's a point here. This point is surrounded by 360 degrees, right? Any
Yes.
point outside of here,
Well,
you're going to
well,
have
no.
to find it by finding a 360
Either-
degree paradigm on either side of the circle. If you're
But
on
there
the
aren't
inside or outside,
degrees
you
inside
still
of inside of a circle.
you have to
Degrees
take
are
it into
things
account.
that you can't form angles with with shapes that don't have straight lines.
Yes, you can.
What?
Okay, so the golden ratio
when?
is 1.6185. Okay, that's the golden ratio. Pi is 3.14. Okay, I'm telling you, you got to understand where I'm coming from here. Now, the golden ratio is how you get angles out of a circle.
No, it's not.
No.
Yes, it is.
You can't do that with. What does that mean? There aren't any angles in a circle. You can't make angles with curved lines.
You have a circle here. Look. Okay, you see the circle?
You just drew 3 chords that
now,
connect.
If you start this point, and you do the golden ratio here. Okay, you have pi. The version of pi to this is going to be your differential to find the angle of an angle. A point between this, which is 1.6185, and this point, which is 3.14. Now you take the radius, which is the half of the circle, and you use the radius and from the radius to the outside of the circle to set a point. Once you set that point, you can have 3 points within that circle, and those 3 points could be a triangle, could be anything. But you have to use the math of the golden ratio, which is basically Fibonacci sequence to pi, and you will be able to make anything you want inside of that sphere or that diagram.
Okay, make something.
Okay. So let's say.
And what is the value of the Fibonacci ratio? I just want to know.
So you have notches on this representation. Okay.
What up, Globe Man?
It's a constant flow. From the center of the circle out is the Fibonacci sequence. At the edge of the circle, or the end or the side of the circle, is going to be radians. So you take your radians and you go by your actual spiral diagram, and you will be able to find a point inside of this sphere or this circle. I'm saying anything, any mathematical equation you want, you can find that angle in there.
Learning some fun stuff, I see.
I don't.
Okay, so
Somebody said these are triangles.
Sequence. It's literally used in all types of mathematics.
That looks like when I play Wizard 101, there's like a little spiral thing in there.
Okay, so if you look, this is what's called. This is used to determine orbits inside of models for the solar system and everything. They use this exact same math with radians divided by or multiplied with the angle of the Fibonacci sequence. This is how we find concentric orbits and stuff in space, and you're laughing at it.
What?
Who's they?
I just don't get the point.
What are you talking about?
I don't think that's
NASA,
I don't get
man.
the point.
NASA, man. Look, okay, you have this Fibonacci sequence, which is 1.6185, right? You have pi, which is what, 3.14. That's going to be used in the radians of a circle. Anything that you're using the radius from the center point of the circle is going to involve this number. So you take this number and you use this as your modifier, and your modifier will dictate along the extension of the spiral to give you a certain program or part.
Matthew, you following this? I'm not following this.
I'm following it 100%, and it's a complete bastardization of trigonometry.
What are these things called?
Okay, thank you.
And it makes all these spirals. So
what's happening? What's happening, Trey? Is I think you're misunderstanding a couple
it's also
of concepts.
called how we find Lagrange points in mathematics.
Hey,
it's Lagrange points in orbits and cislunar navigation.
That's really not how they do it. That's really not how they do it. But you're having a problem where you're kind of taking different aspects of trigonometry and kind of just stacking them on top of each other in ways that don't make sense.
This is what the math does for you, bro.
The math ain't math, bro.
Your math ain't mathing. So
this is math. This is if you don't look up. Go look up cislunar orbits and calculations of cislunar orbits.
Cool. I heard
cislunar orbits as opposed to translunar
cislunar orbits. It's what they're using to make Artemis missions, to dictate the missions and what they are.
Okay,
just go look it up.
Hey, Trey.
Yeah.
So the basis of the information you're talking about right now is like really surface level trigonometry. It's the use.
Why are you insulting it? Why don't you just go look at what I'm looking at? Why do you try to straw man me, bro?
I'm not straw manning you.
I'm
talking about.
Go look at what I'm talking about and tell me it's not the same thing. Go look at what I'm talking about and tell me it's not the same thing. Go look at what I'm talking about and tell me it's not the same thing.
How can you call me? How can you say I'm straw manning when I haven't gotten more than like 3 words out? But
because you're condescendingly saying I don't know what I'm talking about, and you're trying to dismiss what I'm saying.
I'm not condescending or dismissal.
I'm not stupid. So either go look at it or just please stop talking to me.
You're defensive.
Hey, man, nobody's saying
because I deal with this on a daily basis. People like you who think they know everything and don't know their ass from a hole in the ground are sitting there telling me that I don't know what the fuck I'm talking about. I get pissed about it.
So that's kind of what we call the Dunning-Kruger effect.
You're the Dunning-Kruger person, man. You don't have the capacity to talk
about.
Hey, man,
you're getting defensive.
Just let Matt
yelling.
Just let Matt get his entire point out.
So the base
Can he get
level
it without insulting me or attacking my intelligence?
We're talking.
Just let him finish what he's going to say.
There's nothing insulting about this, Trey. Nothing insulting at all. The base level information you're talking about is basic trigonometry. We're talking about the use of the angles of a triangle to come up with unknown information. And the information you're talking about is using external angles or internal angles to figure out missing information in a problem. And that's something that we do use. We do use external angles and internal angles in trigonometry to find unknown information. But when we're talking about just the internal angles and external angles of a shape, the external angles are always going to be more than the internal angles in any shape that has angles. When we're talking about something like a circle doesn't work in trigonometry because it has no angles. All right, a circle has no angles. It's comprised of 360 degrees, but has no angle itself. It is a solid round shape with no actual angles. That's how it's defined. So every single shape that has angles is going to have a greater external number of angles, or the value is going to be greater than the inside. Okay, and when you jump into radians is just a different measurement scale for like the angles of a circle. So that 360 value isn't the same in radians. It's no longer 360. It's just a jump between degrees and radians. It's like the difference between inches and kilometers, right? There's just different ways of measuring the same thing.
Yep.
So there's no real jump back and forth between those. There's no comparison, really. It's just different units of measure. And now when we talk about like pi versus like the golden ratio, these things are literally just ratios. All they do is they measure one thing in comparison to another. So pi is just a comparison of the circumference of a circle to its radius. That's the only thing it does.
Look, man. I literally, I've been sitting here being quiet and being nice. Can I say something?
Yeah, I'm almost done. And just the same way the golden ratio is no more than a ratio. It's just a comparison of two things, no more. It always comes out to be the same value, but it's still just a comparison. Do you know what the difference
between something that is empirically used and something that is just like transcendental? Do you know what transcendental means?
Yeah, it moves. It's not. No, the same
that
thing
means
all the time.
That means it exists without any type of inspiration. So it can be looked at in the environment.
That's not really what it means, but sure.
Okay. Don't interrupt me. Don't interrupt me.
Transcendental does not mean without inspiration, though. That's not what that actually means. But sure.
If I swear to God, dude, I will leave. I'm so tired of you people not knowing anything and acting like I don't know what I'm talking about.
You don't.
Okay, go look it up.
Go ahead and look it up. Look up transcendental.
There's nothing wrong with disagreeing. That's the spirit of debate.
Literally, what does the word transcendental mean? Go look it up. Prove it. You state your claim.
an idealistic philosophical and social movement which developed in New England around 1836 in reaction to rationalism. Blah, blah, blah. It doesn't describe what it is. Based on the idea that in order to understand the nature of reality, one must first examine and analyze the reasoning process which governs the nature of experience.
Which means it was there. It was preeminently expressed in the environment.
I mean, this says transcendental relating to a spiritual or non-physical realm. Like, we say certain things transcend whatever, and that just means that the broader scope of it goes beyond the thing itself. Like, we say that like there are certain like professional athletes, and we say they transcend the sport.
That's not
because it means like they do like community service, or they do like some sort of whatever. Like Muhammad Ali transcended it because he was about things that were bigger than himself. Well, that's what transcendental means.
No, transcendental.
Either way, it doesn't mean without inspiration.
It does mean without inspiration, because there's no one can take credit for it. If no one can take credit for it, then it is transcendental.
There's plenty of empirical things that can't be taken credit for that are just natural.
No one can take credit for finding pi. Or creating pi. No one can take credit for finding out what the golden ratio is, because it existed preeminently.
Nobody takes credit for making pi. Pi existed prior to, but people did
That's what I'm saying.
The ratio between a radius and a circumference. Yeah. That's meaningless. It existed prior to, but it was still discovered.
No, you're saying it's arbitrary. That's not arbitrary. That's not meaningless. That is very unmeaningless.
I didn't say it was arbitrary. I said
arbitrary
it was
means
simply a ratio between circumference and radius, which is exactly what it is.
And it shows what? What does it show?
It
shows either
the radius by the circumference, or the circumference by the radius. That's all that pi does.
And it helps us find angles. Do you know, since you understand the Pythagorean theorem, you can. So you understand the Pythagorean theorem.
What we're talking about.
What angle does pi give you? What is pi?
What are we specifically talking about right now?
Yeah, let's get on topic.
You're jumping back and forth between like circles and
I can't help that you can't laterally think. So I can have one idea here, and I can
you're taking. So if you can't keep up, you're taking those two ideals and you're putting them on top of each other and coming up with really strange conclusions that don't actually fit reality.
No, you believe in really stupid things that make you think you believe in reality.
Because I understand that pi is a ratio between radius and circumference.
Yeah, duh. I think I know too. That's what my point was.
Okay.
Yeah, and so
I may not be a smart man, but I know what radius is.
What's the difference between degrees and radians?
Degrees and radians? Radians are found on the inside of the circle. Degrees can be found on the outside.
You do not have any degrees on the outside of a circle.
Yeah, you do.
No,
so you're saying
that's not how circles are measured.
A circle, there's nothing.
You're telling me there are 360
you don't know how circles are measured. Honestly, you don't know. Okay, so an orbit, nobody measures the outside of an orbit. It has an ecliptic in it, and there actually is a bulge, a tidal bulge. We don't measure tidal bulges.
There are no angles on the outside of a circle.
Negative super humps and light curves, none of that stuff.
There are no.
I don't know if he's confused about the methodology of the approximation of pi. I think that's what he's trying to get at.
We can't measure angle. When you measure angles within a circle, you start from a fixed point in the center of it, because that's the only way to create like straight lines. You can't have straight lines outside of the circle.
And then go outward with the golden ratio to a point.
But the angles will be. Where do you start measuring an angle when you start on the outside of the circle?
On the outside of the circle, you measure from the edge of the circle you measure from the center of the circle outward. If you know that you measure past the radius,
you're not measuring anything on the outside.
You measure on the inside of the circle.
You're not measuring anything on the outside then.
Let me show you something, okay? You have a circle, bro. You You have a circle. If you put a center in the middle of that circle, that's going to be called the barycenter of mass between two circles, right? Yes. Let's pretend that's going to be the barycenter, right? That this circle, things on this circle revolve around the middle of that circle. Now, if something is measured from the interior of that circle to the exterior of that circle, you have to measure the radius. Okay, you measure the radius, then you add from the radius. The distance outside of the radius is going to be what? Outside of the orbit.
That there are no degrees on the outside of a circle. No. It's all at the center point of the circle.
It's like...
So you're telling me
you create angles from the center point of the circle.
Yeah.
There's no such thing as there is an arc measurement around the exterior of a circle, but that's measured by taking the point at the center, making an angle just like Peterson has, then measuring it there. There's no such thing. There's no such thing as an angle measurement on the exterior of the circle.
Are you pro photo, Josh?
No.
No. Yeah, he's not here.
So, and also, I don't think we should keep saying orbit and circles, because orbits definitely aren't circles in reality.
I'm gonna be honest, guys. My phone's about to die, and I don't know how much more words tonight.
I Neil deGrasse Tyson. Okay, look.
Have a good one.
Okay, you see this? This is going to be the center. You have 2 planets.
Big love, man.
And these 2 planets are going to do a dance as they move around this circle. Okay, you're going to see this. It's going to move in here. Then you have here, you have here, and you have here. This is how Ptolemy found the geocentric orbits. Now, what this is I'm showing you that these 3 points make a triangle, and as these three things move about the imaginary fixed axis, you're going to see that these
kids with spirographs make crazy shapes as well. That doesn't change the math of a circle.
Yeah, it does. If you have to take into account, I can't draw damn circle. Okay. There.
What you're doing is you're playing with geometric shapes.
No, I'm not.
And you're calling them the wrong things.
No. Okay. Do you see what this is? Okay. If this moves this way,
that is a line.
An amount. Shut up.
Just let
this moves this way in degrees. Would you say that this correlates and moves the same amount?
No. The further you get out, the more it moves.
All right. Shut up then.
I didn't quite understand what you're saying. Say it again.
The further you get out on that line, the more distance is traveled by the object.
Yep.
Right.
So what would happen if we had to draw here to here? Would they be the same degree? Would they be right angles? What would they be? What would they be?
The angle would be the same.
The angle's the same, but the distance.
And the angle is always measured at the center point. The angle is always measured at the center point.
Yep.
Always measured.
It's the point of reference.
So if you have right here to right here, and you have a circle in the middle of this, see, I want you to see what I'm saying. I want to show you this now. Okay.
Careful, don't flash any addresses on the mail.
Oh, there's not an address, bro. There's no address.
Cool. I'm just double checking.
Okay. Yeah. See, this is just a blank envelope. Okay. This is moving here, and we stop this line here, right?
Sure.
This is where it stops.
Sure.
Mm-hmm. Now, the distance traveled here and the distance traveled here is going to be different, right?
Yeah.
Okay. That's all I want to know. That's all I wanted to know.
Yeah, the distance traveled doesn't matter when we're talking about the angle.
How do you find the length of? How do you find the distance traveled here from the distance traveled here?
Trigonometry.
Right. Okay. Now, if this moved all the way over here, would you say the angles that you find from a point here to a point here, and you triangulated them? This is called what, by the way? If we triangulated from the end of this to the end of this,
it's a hypotenuse, yeah.
Right. Why are you giving me such a hard time?
I don't think we're giving you a hard time.
You asked me what that was. So no matter what length you make those legs, all that will change is the length of the hypotenuse. The angle from the center point of that circle will never change because it's only measured at the center point of that circle.
That's my point. That's my point.
So again, all these ratios you're talking about, they don't really come into play.
This
Like I said,
triangle
you're doing basic trigonometry, just like I said when I came in.
No. You have triangulated 3 objects inside of a circle, and now you can dictate or find out where it's going to be utilizing the golden ratio and pi.
Not the golden ratio in pi. No, that's not how you
Yes,
you use
dude, are you serious right now?
Sine, cosine.
Is the golden
and
ratio
tangent,
is it a straight set of numbers?
What you use is sine, cosine, and tangent to find the angles, to use trigonometry to find these locations and distances. All you need is the golden
ratio. You literally can
because the golden ratio doesn't do that.
Yeah, it does. That's why it's called the golden ratio, bro.
It really does not, Trey. I'm telling you right
That's
now.
not why. That doesn't even make sense. How could that possibly be why it's called the golden ratio?
It's not why it's called the golden ratio, man. Its reason is because that number can be put in place and could give you very accurate predictions.
No, see, the golden ratio is just a ratio. It's literally just a ratio, meaning it is a comparison of one thing to another. Now, when we're talking about the golden ratio, it's a comparison of one circle to another circle, and it's fine, cool. It doesn't give you the information you're saying. Just like pi is a ratio between a radius of a circle and the circumference of a circle, but I'm not going to use it for a triangle because it doesn't do anything for a triangle. I'm going to use trigonometry. I'm going to use
your brain does not.
You can't use the golden ratio for it either.
Can you eat eggs and grits at the same time? Have you ever had eggs and grits?
I don't think we can make that correlation, Trey. That's a totally different.
Sine, cosine, and tangent to be able to find the information on a triangle you're looking for. That's how trigonometry works.
Dude, I bet you're hell in the bedroom. That's all I got to say. You were just like...
What does that have to do with anything?
I can actually find what I'm looking for.
You're just so...
man.
Okay, guys, we're gonna have to pick that up later, because now I don't even know what the hell is going on.
I mean, I understood every...